Welcome to this explainer. Today, we're unpacking a fascinating and frankly, increasingly urgent topic for developers everywhere. We're talking about the hidden cognitive risks of AI-assisted coding. But more importantly, we're going to look at how we can actually use new plugin architectures for tools like Codex and Claude Code to fix those exact risks. Because look, if you've ever felt like your AI tools are making you insanely fast, but you suddenly realize you can't write a standard for loop from memory without asking for help, well, you are definitely not alone. Okay, let's dive into this. Here is our roadmap. We'll start with the AI coding trap itself and the 5 cognitive failure modes behind it. Then we'll introduce the learning opportunities skill, look at how the exercises work, peek under the hood at the architecture, and finally talk about setting better learning goals. Starting off with Section 1, the AI coding trap. Let's just address the elephant in the room. We all know that AI coding assistants are delivering this absolute massive productivity boost. We are shipping code faster than literally ever before. But alongside that speed, there's this creeping, quiet doubt that so many developers are starting to feel. It begs the question, is AI coding actually making us forget how to code? Are we building our expertise, or are we really just building our code bases? It's not just imposter syndrome anymore. This is a widespread, real industry fear about agentic tools taking over the heavy lifting. There's a recent breakdown of this phenomenon that really hits the nail on the head. It says, when Codex or Claude Code writes your code, you read and accept. You don't generate, predict, or retrieve. And that right there is the crux of it. While this passive acceptance is absolutely amazing for hitting your sprint deadlines, it systematically bypasses the actual cognitive work our brains desperately need to build durable, long-term expertise. Just think about the contrast for a second. The old way of learning to code, it involved active problem solving. You had to sit there, struggle to produce an answer, pore through the docs, and test yourself. It was hard work. The new AI way, though, is all about passive acceptance and rapid machine velocity. We are successfully bypassing that cognitive load, sure, but in doing so, we're kind of accidentally optimizing away our own learning process. Moving on to Section 2, 5 cognitive failure modes. To really understand why our skills might be atrophying, we can turn to Dr. Kat Hicks. She's a psychological scientist who studies software teams, and she's outlined 5 predictable cognitive failure modes caused directly by the structure of these AI-assisted workflows. We've got the generation effect, the fluency illusion, the spacing effect, the metacognition gap, and the retrieval deficit. Let's zoom in on 2 of the most dangerous ones for us developers. First up is the fluency illusion. Okay, have you ever read an incredibly clean, beautifully architected block of code generated by Codex and thought, yep, totally makes sense? Of course you have. But that easily accessible knowledge promotes a false belief. It tricks us into thinking we actually hold a true mental model of the architecture. It reads as understood, even when we don't actually understand it well enough to recreate it. So the crucial point here ties into the generation effect. Learning science has proven time and again that generating an answer yourself cements knowledge. By constantly just hitting tab and accepting generated code, we skip the active processing required to build long-term understanding. We're essentially reading instead of writing, and our memories are paying the price. Which brings us to Section 3, the learning opportunities skill. Now that we've properly diagnosed the problem, let's look at a pretty brilliant solution. It's designed specifically for this modern workflow, and it's called the Learning Opportunities Skill for Codex and Claude Code. Think of this open-source plugin as a dynamic textbook for deliberate practice. It's built to actually expand your expertise right while you ship code. Instead of forcing you to close your IDE and go watch a course, it interrupts the passive pattern of AI coding by bringing the learning directly into your current context. It nudges you to invest in a little reflection. So how does it do that? Well, here is the interception loop. Let's say you just finished some heavy architectural work. Maybe you added a new database schema or did a major refactor. The plugin watches for this and subtly intercepts your workflow. The agent pops up and says, hey, want to do a quick 10 to 15-minute semi-worked exercise based on the code you literally just wrote? It's totally optional, but highly effective. Let's look closer at Section 4, how the exercises work. And this brilliantly illustrates the practical side of the tool. Because remember, these exercises aren't generic textbook trivia. They are dynamically generated from your living code base. It maps psychological goals right to practical tasks. If the cognitive goal is prediction, the agent might hide the migration file you just wrote and ask you to sketch out the rollback. For retrieval, it might ask you to explain your brand new dependency injection pattern blind. If you struggle to explain it, Well, that's a real gap in your knowledge you just discovered. But here is my favorite part, and it's a core design principle. The agent pauses and waits for your input. Think about how completely unnatural that is for an LLM. We have trained these models to immediately blurt out the complete answer. By explicitly forcing the AI to wait, the plugin pushes back against the tool's default nature. It ensures that you are the one doing the mental heavy lifting, not the machine. All right, let's get technical in Section 5, Under the Hood, Architecture. So, how do we actually wire up this cognitive safety net inside our tools? Building a plugin for agentic environments like Codex relies on a standard directory structure. You've got your plugin.json file that acts as the manifest containing your unique namespace. Your actual AI capabilities live over in the skills directory using Markdown and YAML front matter to tell the model exactly when to trigger them. And finally, the hooks directory holds the event handlers that are silently watching your workflow. Now, why build a full plugin instead of just a quick local script? Well, you absolutely could build this standalone in a local folder for personal experiments, but the packaged plugin approach is a real game changer. By using a unique namespace, the tool can be version controlled and shared across your entire engineering team via a marketplace, all without causing messy command conflicts in the terminal. The skill also deeply integrates with some killer features of these agents. For instance, it uses a post-commit hook so it knows automatically to prompt you right after a git commit. Inside Codex, it can even spin up background Git work trees to generate these lessons without ever messing up the active branch you're working on. Add in native Windows sandboxing support and an optional companion skill called Orient that samples unfamiliar code bases for you using expert navigation, and you've got a powerhouse learning environment. Finally, let's wrap up with Section 6, Setting Better Learning Goals. Because look, having exercises pop up is really only half the battle. You have to actually want to do them. That brings us to another companion skill developed by Dr. Hicks called Learning Goal. This provides the motivational framework to stick with the program. It uses a proven psychological framework called MCII, which stands for Mental Contrasting with Implementation Intentions. Why does this matter? Well, research actually shows that purely positive visualization, like just imagining how awesome it will be to master Rust, can actively reduce your drive to do the work. Your brain feels like it already achieved the goal. MCII fixes this by pairing that positive visualization with a brutally honest assessment of concrete obstacles. So the Learning Goal plugin literally coaches you through this in a quick 10-minute chat. First, the agent helps you set a SMART goal. Then you visualize the outcome. But crucially, it pushes you to identify the real messy obstacles that will get in your way. Then you build concrete if-then plans, like if I get stuck on a bug for 20 minutes, then I'll trigger a learning exercise instead of blindly asking AI to fix it. Finally, it produces a markdown card you can just pin right to your project repo. Which brings us right back to our ultimate question for today. Are you building your expertise or just your code base? By taking advantage of plugins like Learning Opportunities and Learning Goal, you can genuinely reclaim your cognitive development and stop the AI coding trap right in its tracks. I highly encourage you to install these plugins and just try out an exercise on your very next commit. See how it feels. Thank you so much for joining me on this explainer, and happy mindful coding.